Everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. Okay, so today's challenge is a little bit interesting one. So let's see the problem statement at first and then we will go to the solution. The solution to code might be very simple, but yeah, this is a totally different type of concept which you need to understand. Okay, not much different, but yeah, some people call it a different kind of data structure altogether, but yeah, I will show you how to have its intuition really easily. So you are given an array nums of size n consisting of non-negative integers. Your task is to apply some possibly zero operations on the array so that all elements become zero. Okay, so you are given an array of numbers, non-negative numbers. You need to make all of them zero. What you can do, you can perform some operations. Okay, you need to find the minimum number of such operations. In one operation you can select a subarray and make all occurrences of the minimum element in that subarray to be 0, and you need to return the minimum number of operations. Okay, so let's say consider this example 2. You can select this whole subarray 1 to 1, and what is the minimum element? It is 1. So all occurrences of 1 you can just convert it to 0. You will be getting something like 3020 after that, and you can now select this small size subarrays. So you can, let's say, select this subarray and turn that to 0, and select this subarray 3 and turn that to 0. So I hope you do get what we want to do exactly in this problem. If you try to see this example, you can select this whole subarray, okay, or even this one also, the whole thing, and the minimum elements are 1. So all the occurrences of 1 you choose to select and make them 0. And now you see, if you try to select some element like 202, the minimum element is 0. So you cannot convert the 2's to 0 in this manner. So for converting all the 2's to 0, you need to select them one by one, and you will be wasting some operations on that. So yeah, that is the only optimal thing in this case, and you get all zeros in that such number of so many times. Okay, so I hope you do get what to do exactly in this problem. I want you to have some observations. Okay, so first definitely try this problem on your own and then continue watching the video. So I will try to make some observations. Okay, so what are those observations? Let's say you have something like 4, and let's say there is a 2 over here. Let's say after some numbers, dot dot means in between there are some numbers, and here is a 4, and yeah, in between 4, let's say there exists only 7, 6 and again 4, and let's say there are some more numbers. Let me write the numbers. Okay, so 5 and let's say 8, and let's say something 2 is here. Okay, so what I want to tell you is that when you are selecting a subarray, okay, so let's say there are some occurrences of large element. What I want to say is that, let's say a 5 is there, a 5 is there, and in between a 2 is there. So if you are selecting this subarrays, okay, there are some numbers in between also. If you are selecting this subarray, you cannot convert this 5 to 0, both of this 5 to 0 in one operation. You cannot do that because the minimum element will be 2, and you would want to select that only. Okay, because that is the rule. We need to select the minimum element and then turn it to 0. So through this example, what I want to show you is that, you see, you can convert this 4 and 4. You can select both of these, and see, in this subarray the minimum element is 4, so you can transfer both of them to 0, and let's say you can just, if you try to take after that, so let's say after that what will be remaining, it will be something like this. Okay, so after this, if you try to take 2, you see zeros will also be coming, which is less than 2, so you cannot select 2 in such a case. So what you can do in such a case? First you can select this whole subarray. Change the 2's to 0, because in this whole subarray now the 2's are only the minimum element. Okay, and after this you can choose to select this. In this way you will get in 2 operations. You can empty 4 elements. Okay, see 4 elements you have emptied. But what you cannot do, what I was trying to say in this through this example is that, let's say there is another 8 and 4 over here. Can you select this two 4s and convert this to I mean, can you select this whole subarray or this subarray and then transfer those all these 4s to 0? Can you do that? No, because you see in between there is a small number 2. So whenever you get a small number, you cannot go ahead of that. So what I want to say is that, let's say you have a number, let's say 6. Okay, you are trying to find some, you have got some duplicate elements in its back. Okay, and 8 is there, let's say 9, 7 is there, so you have got 6. But let's say after this you get, let's say 7 also, but after this let's say you are getting some element which is less than the 6. Okay, so if something is dropping, what I want to say is that if something is dropping from 6, it drops to, let's say 2. So then all of these 6 or whichever elements which are left of 2 cannot possibly form a sub array with something to the right of 2. Okay, what I want to say, I hope you do get it right. See, if you have a small element in between, to the left of all these elements you cannot form a sub array. So you cannot form a sub array starting from the left end and ending to the right end, because in that case you will be selecting this minimum element and your 6s and 7, 8, 9, those will not be selected anyways. So whenever you try to take account that see your element is increasing, let's say again increased, again increased. So I'm trying to draw a bar graph type of thing through the array. Let's say this is the first element, is the second element, this is the third element, this is the fourth element, so on so on. Whenever you see that I am dropping, whenever you see that I am dropping, you need to select all of those elements to the left of those, left of this particular element. Okay, whichever is there in the left of this particular element, you see you cannot club these elements with whatever will be coming to the right. So let's see you are having an iterator I which goes from 0 till n. Okay, and you are coming across some element which is less than them. Okay, less than this element, then you see you should go on iterating backwards again till the time you delete all of these elements. Okay, so for this definitely you can use a stack. I hope you do get it right. So you keep pushing each and every element in the stack as long as the stack is increasing, the elements are increasing. But whenever you see a downfall, whenever you see a downfall, you immediately try to delete all of these elements which are less than this particular element. So definitely this is the element which you need to delete, and maybe some more elements also, because those elements cannot club with anything which is to the right of this element and make it 0, right? So why not make it 0 now only? So that's what, that is the main thing which you need to do. And if the things are increasing, if the things are happily increasing, you can just keep pushing them into the stack to keep an account of whichever elements are there. So if you try to code this out, it will be very simple actually. So let's see, we will try to keep a vector as a stack. Okay, so let's have this as a stack, and what I can do is that let's say I am doing a simple iteration at first. Okay, let's have an answer also to 0. I am trying to do a simple iteration, int a nums. So I am going through all the elements of nums one by one. A is the first element, second element, and this, I hope you know this iteration. Okay, so when you see that in my stack the last element is actually greater than my current element. Okay, so while stack dot back, you can tell that the last element is actually greater than this element, keep deleting those last element. This is what I want to do. But hey, this can be empty also, right? So make sure it is not empty. Stack dot empty is not of stack dot empty, and stack dot back, it means that the last element which I encountered is greater than this element. It means that I see a downfall. Whenever I see a downfall, I keep popping back all those elements, because there is no use, see they cannot expand to the right more. Okay, and what you can do also is that if you see the stack is empty, then you have to do nothing but insert that element, or you see the stack dot back is less than a, then also you can just push back stack dot push back a. Okay, so you can just simply push back elements, and whenever you are pushing back, you see you can increment your answer to this because see all of them will be deleted at some point of time. Okay, and yeah, you will be deleted, and this answer, that only makes sense if you, I mean, when you are pushing some element. Okay, so let's say you are pushing an element. So see, this will not be happening if there are duplicate elements. So if stack dot back is equal to a, this will not be executed. Okay, so this will only be executed when you have something which is less than a. Okay, and you need to actually push that back, and that will actually count as a whole element. Okay, that will count as an element when you want to delete that. Okay, so that's why you increment your answer also, and you can return your answer. I hope this should work. Let's see, let's try to run and check. Okay, so we are getting a wrong answer in one case. Okay, here output is 2, but it is supposed to be 1. So this is the case of 0. Okay, so when there is a 0, uh, there is a possibility that, see, this will not be true, but when the stack is empty and there is a 0, it will end up in pushing back the 0, which we do not want it to happen. If there is 0, you can simply continue, right? So if a is 0, you can just choose to continue. I hope you do get what I'm trying to say, and this will work. There are just 3 cases here. Still, let's try to check, and now let us submit for all cases. So you see, we do get a really decent runtime and memory complexity since we are using O of 1. And if you are thinking there are 2 loops, why it's still O of 1? Because you see, you try to look at element wise. Either you are pushing an element into a stack, or you are popping an element. So at worst case, you are visiting every element 2 times, either for popping it back when you are moving backwards, or for pushing it into the stack. So if each element you in the worst case visit 2 times, then O of 2 into n will be your time complexity, which is nothing but O of n. Okay, so that's what is actually happening. You can look at analyze time complexity, and also look, it is a simple O of n. So yeah, I hope you do get it. Some people treat it as a totally different kind of data structure. They call it monotonic stack. So but no need to think it in such a complicated manner, because it's just a stack which stores increasing elements only. That's why they call it monotonic stack. But yeah, I hope you do get the concept and not just memorize data structures when to use. And yeah, if you just memorize data structure, you will be struggling with things like when to use this kind of data structure. You will be asking questions like, hey, tell me when to use monotonic stack, when to use this, when to use greedy. See, you have a lot of ideas. You just keep your ideas in your mind and just think on the problem, and then think that what kind of thing can be applied here. Okay, not just blindly go to apply some data structures directly. Okay, so yeah, I hope this kind of approach will help you in some of the problems. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.